Mr. James Boras from drilling department have talked about that quite a lot in the morning. I just like to highlight some key main features here. We have two types. One is two sides, one is 3.5 upper and lower completion. We have two wells like that, and that is TG2A and NC3P. The one I show up here is TG2A has actually longer sand screen section. It's around 90 meters of sand screen. Reservoir might be something more than 10 meters, I don't remember, but the sand screen is 90 meters. But we know that we have problem with productivity in this well. So later on, when the productivity drops, we have to firstly try with acid. It didn't work, then we eventually have to perforate it. NC3P have only 3.4 meters of sand screen, extremely short. The second is the same type, the second size is even smaller. Upper completion is only 2 and 3/8. I think that is the smallest completion that people run around the world. The bottom one is a bit bigger, but same problem. The other well of the same size is SD4P, 4.5 meter sand screen. Now, I just like to go back a bit into why we did what we did for the first campaign in 2008. As far as I know, at the time we first looked into the well and decide what type of completion we're gonna run. And we have a third party to do the mechanical earth, something sand study, something about the competence of sand. And the conclusion from out of that study is that the reservoir is good. We can complete the well without having to have sand control in first place. And this basically, all this wording is basically extracted from that study. So with that, Trường Sơn took it and we decided, we designed the well just like what we have on all the SD wells and NC wells. No sand control, we just cased, we run casing, then we perforated. Then when we have the well on, we're starting seeing problem with sand. This is just to list a little problem we have with NS1P. At first we have sand, the sand bridge that fall into the well. We thought that there might be a lot of sand. We mobilized the whole core-tubing fleet out. But then I think we believe we did not see sand on surface. It might be so fine that we couldn't see anything. We also saw sand problem in other wells too, but more on surface. So we say at that time, it is around 2008, 2010 here, that we need to drill infill wells to get more production. Just before that. It is just a couple of photos showing the erosion of surface equipment that scared us. We say, oh, even though third party is saying that sand is not a problem, but we had a problem. So we don't want this, we want to do something different. This is the sand that we took out of NH1P during one of the intervention campaign. It is sand downhole. So we said that we don't want sand. We want oil, but we don't want sand. So in 2010, before the infill drilling campaign, we consulted the services from another third party called VPI, and they concluded basically other way around, that we need to have something downhole to control sand. Besides that, they also say something about gas lift, and to minimize sand, we need to optimize the gas lift. So we take that on and say, okay, now we have another guy, another expert saying we should do downhole sand control. And I think at the time I'm not here at that time, but what I believe was we look around into other operators and we see sand screen. The SAS was run kind of like successfully. So we take that lesson on and say, okay, we're going to run sand screen. A lot of things, a point here, I think James have intensively mentioned that in the morning. I'd just like to list it out here and just quickly go through it. We didn't have core, so we just take the cutting sample and do the basic study to decide what size of sand screen we have. The zone we have is very thin. But I think the other point that is very important too is when we take the lesson from other people, from other operators, we didn't understand that execution at the website is also extremely important. We cannot just take it for granted that this technology works, and we don't carefully put out the QA/QC guideline and make sure that we have clean fluid at the website. So as a result, we do everything not as good as we could, and just after a short period of time, production dropped very quickly. In the morning, we also saw production history of TG2A. So the production was not as good as we expected, very disappointed. We're trying to do remedial action. At first we acidized it. We were hoping that the residual mud cake that we have around the sand screen was not cleaned properly. So by pumping acid, maybe it will help to dissolve that, and then oil will get into the well easier. And hopefully we can stimulate the well too. Unfortunately, it worked 50%. In 2 wells we have pressure increase, the other 2 it didn't quite work. After some time it get back to normal. Then we perforate the sand screen. We get pressure increase though, as we can imagine, because we get bypass through all the sand screen and all damaged zones, so we get direct access to the formation. But then it come back, the problem, the traditional problem come back. It comes with sand too. So now we have to deal with sand. This just show, just for you to have a taste of what it takes us on FPSO to get sand out of a surface facility. We basically have to inject water into the whole system, and then at another point we extract the slurry of sand and the water out and just manually dispose it. Lesson learned we have from there. Number one, again, I think we cannot stress it more enough that core is extremely important. If we like to do apply the sand screen technology, then core is very important. I think that by now is very clear to everybody. And also is that technology, sand screen, is more applicable to the formation that is long, so it has some tolerance. In case that we don't set the screen right on depth, maybe like 1 or 2 meters off, we still have a long section to compensate for that. Or even though we might have some section that buried with collapse formation, we still have a lot of good section for oil to come in. In the case we have with some dock here, I believe it's so sharp, so there's no room for any mistakes. Besides that, the contact area is so small too, as John mentioned in the morning. So we picked the application that's not quite applicable for our situation here. The cleanliness of the surface, thick tank too, and this one is, again, to my personal experience, is very important. When I read back into the report, the method that people use to make sure that the mud that used before running sand screen is just as simple as they have a machine. They get a sample of the mud from the mud pit, and they put into that machine, and the machine will tell us that how clear is the water. It's like, I think the equipment called turbidity machine. So it's more like even though it's a measurement, but it's more like a feeling that the mud is clean, but it's it's not good enough. Whereas what it should be is we should take a sample and we need to measure the solid content. So I think the head lesson have been taken into high sea trunk, and they put a target there for 0.01% of solid. So essentially it's just as good as water. That is what they said, TSJOC team have set out their target. They say they will not stop circulating until the mud is as clean as drink water. They did that, and I think, so thanks to that they have a good result. But we did not do that during the TSJOC time. We just circulate, we did not clean the mud pit enough, so we have dirty mud before we run the sunscreen. The other thing is, okay, so we have one field TSJOC. In 2008, we say we don't need sand control. In 2010, we turn on 180 degrees, we say we need sand control. But neither case seems to work. And I think that reflects the reality. Sometimes we go from one extreme to the other, it does not mean that it's right. It has to be case by case. So, personally, what I'm trying to say here is the reservoir we have there is very marginal and difficult. So maybe either of that is enough. We have to be able to produce the well effectively. We have to study more, and we have to look into the option that's somewhere in between. Not completely no sunscreen or sunscreen only. There's option we can look into, like gravel pack, for example. I mean, I don't mean to say that gravel pack will work, but we know that at least we have other options to look at. But basically, we need to have a lot of information to decide to make it work. We tend to make a quick decision in both campaigns, and unfortunately, that did not work for us. So that is the end of my presentation. Thank you for your attention.